Now we get to the more pervasive linear programming problems. There, the relationships are linear. The reason why these systems are more pervasive is because they occur in man-made systems. Man-made systems tend, by and large, be linear in nature. And so we can solve very large problems of this sort. The general form of this problem is to minimize or maximize some objective, which is some kind of linear combination of parameters cj times the decision variables xj. Those cj's are normally either costs or profits or some other element of the objective. We have many constraints, b from 1 to m. The left-hand sides are linear relationships again. The right-hand sides are constants. And then we can have any combination of greater than or equal to or less than or equal to constraints. The variables are invariably non-negative. There's an exception which allows for variables to be both positive and negative, and we'll talk about that when we get there. An example is very straightforward. Here we're maximizing 3 times x1 plus 4 times x2 subject to these 4 constraints, and of course the variables x1 and x2 have to be greater or equal to 0. Most important thing to remember is that all the relationships are linear. Another very important thing to note is that the form of this linear program is very stark. There are no absolute values, no minimum or maximum within the expressions themselves, no if statements. And the challenge when one is given a real problem to translate it into the stark form is to find ways of incorporating all the details of a real problem into this form. And that is the challenge of formulating problems, and we will speak about that quite a bit later on.